Alright, we're not gonna do that anymore. Okay, are we ready? Pippins, you did pretty well on your quiz. Did you see that score?
Yeah. Thanks.
Okay, I'm gonna give you all the attendance and your uniform. Items are going to give you. By the way, our old phones in the pocket. I got two of you down here that I've confiscated. I'm mad today. Thanks to. So we need to make sure we haven't forgotten. Right? During the daddy. Okay. All right. Here's a review problem from yesterday. This is not on your paper. I don't know where you can do it. Squeeze it in somewhere. But I want to see if you can remember how to do these two problems. So here's the first one. I want you to do it. Look at your notes if you've forgotten. And then here is the other one. Okay. So right now, everybody, including you, are working on these two problems. Listen first.
Are these questions in our packet or is it
No,
just?
these are extras.
Oh, okay.
You're just writing down somewhere, squeezing them in somewhere. We're just making sure, because we're getting ready to try new ones today. And we just want to make sure we have the old ones taken care of. Oops, no Chase. Everybody else is here but Chase. I heard somebody say, I don't know how to read this, that we should have our notes out, because we did a whole bunch of these yesterday.
Is it the one right here? Yeah, it's right here. Line X and Y.
Yeah, I think that's too much power for this little computer.
Come on, bro.
Oh, okay.
I'm checking to make sure that if you're out of uniform, you're allowed to do that. You got those bumps on? Look back in your notes. Come on, quit lotioning up. You done done? All right, I'm gonna ask you for the answers here as soon as I check. All right, hot system, rooted, Sunny? You're not marked this week, okay, together know, we don't have time for that. I'm gonna just, you think you are?
Yeah.
Okay. We'll find out. But not right now, because we have work to do. Waiting, you're not working. Did we talk about this yesterday? I'm gonna check on you and don't let me know if you're okay. You're keeping track of us. Okay. So, Mr. Pippin, what was your strategy here with this problem right here, the first one?
Made a line.
Made a number line. And right smack dab in the middle of the number line, you put a 4. And then you put a dot out here and a dot out here, and those dots will fill with
7 and 1.
7 and 1. How did you get 7 and 1?
Because he added
We started at 4 and added 3 and subtracted 3, right? And then, because it's a less than, he shaded in here.
No.
And the answer he wrote down on his paper is that. On the quiz you took yesterday, I did not mark off if you didn't use interval notation, but going forward, you will lose a half a point every time you don't use an interval. Right? Get in the habit. When do we use intervals? Only when our problem has an inequality. If your problem has an equals, that's just x equals. But if your problem has an inequality, your answer is going to be an integer. Okay? Just like this. All right. Who else? Who had an idea on the second one? Don't even say you didn't have any idea. Oh my gosh. You are math students. When you see that, what do you automatically think about doing? Factoring. Absolutely. Shoot, did I start that thing? I'm sure if I started it now. Oh yeah. Okay. How does this one factor? Minus 6 minus 2. So we're going to do exactly what Mr. Pippins did. We're going to do our number line. We're going to put 2 dots on the number line. This time they are open. The dots will be at 6 and 2. And since it is a greater than, we're going to shade outside. And our answer will be negative infinity to 2, or, and we always use that U as our or, 6 to infinity. Did anybody get both of those right? Some of you did? Good. Our goal is for everybody to get them right. So anybody have a question about one of those problems? All right, today we're going to ramp it up. According to my records, we're ready for 2E on the back of page 6. Okay. Now, we had mentioned yesterday what is different about this problem.
The X is
It's a cube. Now what that means is, eventually, I am going to have my number line, but there are going to be 3 dots on the number line. Because there are 3 x's in the problem, x cubed. I am going to do exactly what I did there. I'm going to factor. Now, if you look carefully at the problem, what do we always do first, Max?
you got to factor out the X.
Yeah, GCF, we take out the x. So when I take the x out, I'm left with x squared minus 2x minus 8. Then, I look at this, doesn't that look like that right there? So I am going to factor that. Keep the x stays. How does this factor x?
-4 positive.
Minus 4 positive 2. Now, do you see why there are 3 dots on the number line? Each of these factors gets a dot. Clearly, that one's gonna be at 4, and that one's gonna be at -2.
So is that going to be 0?
That's gonna be at 0, very good. So -2, 0, 4. On the problems we did yesterday, the 2 we just did here, we had 2 dots. And every time it was a greater than, we shaded outside the dots. And every time it was a less than, we shaded, what does that do?
Shut up. They give you a janky one.
This is, and I'm gonna have a room full of parents tonight, and they're gonna think, what kind of,
They give you a janky one.
outside when there's 2 dots, greater than is outside, less than is inside. There are no rules for 3 dots. So, here's what you're going to have to do, all right? I want you to listen carefully. I have marked 3 dots on my number line. I want you to pick a number that's not already a dot. So don't pick one of these, pick any other number. So when you pick it, 12. Meg's picking 12. So Meg is picking a number out here. Did you agree with me? So she's gonna come back over here, and she's gonna put 12 in for all the x's. So she's gonna have 12 times 8 times 14. Now, don't worry, you don't need to multiply that together. You just need to tell me, if I multiply 12 and 8 and 14, will I be bigger than 0?
Yes.
Yes. That means Meg picked a winner. This section of the number line is part of the answer.
How'd you get 12, 8, and 14?
She picked 12. 12, 12 minus 4, 12 plus 2. You pick any number you want.
Okay.
She picked 12.
Is it always going to go to where the arrow's pointing?
What do you mean?
Like, because it's greater than it's pointing to the right. You
No.
shade it right.
No. I want you to get in the habit, as soon as you start having multiple factors, I want you to get in the habit of getting your zeros up here, your dots, and then just pick one section. Meg happened to pick a winning section. Could she have picked a number that wasn't bigger, that turned out not bigger than 0?
Yeah.
Yes, and then she wouldn't have shaded right there. So you're gonna pick whatever number you want in whatever section you want, and you're gonna figure out if you're gonna shade it or not. You shade it in this problem if it's bigger than, if the answer you get, multiply, is bigger than 0. Let me show you something. Suppose I pick 3. I put 3 in, I get 3, -1, and 5. Is 3 times -1 times 5 bigger than 0? No. So she picked a winner, I picked a loser. She shaded her section, I don't shade mine. Okay? Now, let's say you pick -1. -1, -5, and 1. I put in -1, this section right here, I put in -1. If I multiply -1, -5, and 1, am I bigger than 0? Yeah, so that's another winning section. Let's pick -5. -5, -9, -3. I picked -5. Are those 3 multiplied together going to be bigger than 0?
No.
No. So the answer to the problem is every space that had a winner. So this space had a winner, or this space had a winner. You are going to pick a number in whatever space you want. Here is the good news. I did all four spaces. You don't have to, I need to do one. Because the shading will always alternate. So as soon as Meg picked the number out here and it was a yes and I shaded it in, then I knew this section wouldn't work, this one will, this one won't. It's every other one. No matter which section you pick. So if I was started here, it worked. And it won't, and it won't, and it will. So you don't have to pick all four numbers. You start at one, figure out if you shade it or not, and then alternate. Alright, let's try another one. What is your thought about how to do problem F? Any ideas?
Take out the x.
Take out an X.
So x times
And what's that leave me with,
x
Brian?
squared minus 1.
X squared minus 1. How about x squared minus 1? Talk loud, I can't hear you.
How's it negative 2?
How come what? None of these dots are closed. So when the dots are closed, you always have regular parentheses. On here, the dots are going to be closed. All three dots here will be closed because of the or equals. But I'm still wondering what I do with x squared minus 1. How does it factor, Isaiah? You gotta really scream that there. X plus 1, x minus 1. It's called the difference of squares. So my dots are at 0, negative 1, positive 1. Make sure that you put them on there in the right order. Okay? Now, you only need to pick one number. Any number is fine except these. Don't pick a dot. Pick a different number. So, Monica, what do you want to pick this time? Negative 1 is a dot. You gotta pick a number that isn't a dot. So you're at 2. We can do 2. So if we put it, 2's out here. This is where 2 is. So he's gonna see if he's gonna shade out here. So he's gonna put in 2. There's 2, 3, and 1. Run it. If I multiply 2 times 3 times 1, am I less than 0? No. So guess what? That's a loser. We don't shade it. If I don't shade that one, then I will shade this one. I won't shade that one, and I will shade this one.
So you go every other one.
Every other one. Every other one. You have to try one first.
Could you, on the number line, could you put X instead of zero?
X? No, I have number. I have number. Next, this factor right here is like x minus 0. That's why it's 0. Alright, so negative infinity to negative 1 or 0 to 1. That's my answer this time. Alright, now we're going to do a little physics. You do not have to memorize this formula. You do not have to memorize this formula. I will give you this formula, but you'll have to know how to use it. right? So you don't have to know what all this stands for. Okay? Now I'm gonna make your life a little easier. You remember the whole f of x, right? And f of x function notation is the same as y. Do you remember that?
Yeah.
So I'm gonna go ahead and think of this as y. It's not f of x, but it is s of t. It's the same thing. So I'm just gonna think of it as y. And it represents the height, oops, I spelled it right. The height after t seconds. So our y is going to be the height of an object that we have thrown or kicked or something. It's called projectile motion. And if we want to know how high it is after 2 seconds, this formula will tell us. T is your seconds. V sub naught, this guy right here, is called V sub naught. Naught, like 0. V sub naught is the initial velocity of the object. So, let's pretend I play football. I throw that football. The velocity that it leaves my hands would be the initial velocity. Okay? By the way, I did play practical football in college.
Really? What college?
Anybody want to guess what position I played? It was not quarterback. I was not.
Safety, kicker.
I don't know what is a
Corner?
safety. I might have been a safety.
They're on defense.
Holder.
Yes, I think no, what I was a defensive back. Is that a
Oh,
safety?
yeah. It's like, it's kind of like.
Hey, that's me right here.
My job was to go get whoever had the ball.
Yeah.
Yeah. Okay. S sub naught. There's a T hooked to that, by the way, you guys. There's a T hooked to that. Okay? That's seconds, but don't lose that T when you write your equation. S sub naught is the initial height. So let's go back to me throwing the football. The initial height would be like around 5 feet. If I threw something off the top of the building, the initial height would be like 18 feet or whatever. What if I kicked a ball from the ground? It's on the ground and I kicked it. What would be the initial height there? 0, right? If it's on the ground, the height is 0. This number is whatever your initial height is. So, let us read problem 3A, or problem 3, and figure out what equation you're going to use. So here we go. Y equals negative 16t squared. That part never changes. What is my initial velocity?
18 feet per second.
So plus 18t. The ball is thrown off the top of the building 12 feet tall. So what is my initial height? 12. There is your equation.
Factor.
Now wait, let's go through. So step 1, this is a multiple part question. Part 1 is going to be write your equation. Then we can start answering the questions, okay? So here come the questions. When will the ball hit the ground? So let me kind of draw a picture of this. Here's the building, 12 feet tall. I've thrown it up. Would you agree that at some point it's going to come down and hit the ground? Okay. How am I going to figure out when that is?
What's that equation?
Well, what would I do with that equation? Yeah, I can use that equation. What would I do with it? Make y 0. why is she making y 0? Because what is y? What is y? The height after t seconds. So I want to know, when will my height be 0? When will my height be 0? That's what I want to know. What kind of an equation is that? Quadratic, x squared. So what are your choices with x squared equations?
Oh, no, you can guess and check.
You will guess and check, that would be a nightmare. You can always
Factor.
guess and check, I'll let you do that. And you can come back with your answer after I'm retired, because it's gonna take me that long. So, what am I gonna do if I'm not guessing and checking?
Factor.
I might try to factor. I'm looking at these numbers and I don't wanna mess with that. That's like, maybe it factors, but look at all the combinations you have, I just can't deal with that. So, is that thing running? Okay. So, what's another option? Quadratic formula, that sounds like our best option. This is where the numbers are big. Who cares? I have a calculator, right? So here we go. T equals, that's like x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. It isn't pleasant, but that's what it is. Alright, so negative 18 plus or minus the square root of 1. Let's figure out what this is right here. I got 1092 for all of this. Anybody else get 1092 over here? All right, let's look. We have two answers. One of our answers is negative 18 plus the square root of 1092. And the other one is negative 18 minus the square root of 1092. So, can everybody get from here, which was our setup, to our two answers, which are here and here? We're going to figure out what those are decimally. But everybody good getting to that point? All right, let's type them in. So negative 18 plus the square root, did everybody find your square root button over here on the side? Square root, 1092 equals, don't forget to hit enter, and then divided by negative 32. Did you get negative 0.47? All right, now let's do this one. Negative, and by the way, negative is this down here at the bottom, right? That's a negative. That's your negative. So negative 18 minus the square root of 1092 equals divided by negative 32. I got about 1.6 for that one. 1.595. Everybody get that one too? All right, what was the question? When is the ball on the ground? What do you think the answer is? 1.515 seconds. Why am I not picking negative 0.47? Because it's negative. Can time be negative?
No.
No. So in terms of the picture, if I drew the whole parabola, that would be back here. It's on the ground back here, but the problem started here. That doesn't count. So that answer gets thrown out, and the only answer is 1.595 or 1.606 seconds.
Where'd you find that at?
I typed this in on my calculator.
Sorry, because you got negative 0.47, so I was like,
I got both of them. I did them both.
Oh.
There's two answers. I typed them both in. All right. When will the ball be 15 feet above the ground? This is question B. When, using the same equation, this is your equation. When will the ball be 15 feet above the ground? What am I going to do there? Isaiah? Exactly. Isn't this the height? So I'm going to make that 15. Now what do you think?
make it 0.
Exactly.
So do you subtract 15 there?
Yep, I minus 15. And then what? Do it all over. So x equals negative 18 plus or minus the square root of 324 minus 4 times a times c. So it looks a lot alike, but it is a little different, so I got it. I went ahead and did this math under here using my calculator, and I got 132. Double check that. Make sure I did that right. Anybody else get 132? Thank you. All right, so here are my two answers. T is either going to equal negative 18 plus the square root of 132, or negative 18 minus the square root of 132. Now when everybody typing, we're going to type that in, and we're going to hit equals after we put in our numerator. So negative 18 plus the square root of 132 equals divided by negative 32. I got 0.203. Anybody else get that?
You got point what?
203 for
Can't even
one of
see
them.
it.
I've done the other one. Negative 18 minus the square root of 132 equals divided by negative 32. That one is 0.922.
So they're basically 0.922.
look, anybody else get .203 and .922?
Yeah.
Okay, so Trey is asking, okay, so which one's the answer? As it turns out, they're both answers. Can somebody explain to me, go back to the question, when is the ball 15 feet above the ground? Why are there two answers? One's on the way up and one's on the way down. Remember, the ball was thrown from 12 feet. So 15 feet is about right here. It's at 15 feet on the way up, and then it's at 15 feet on the way down. So there are actually 2 times that it's 15 feet above the ground. Okay? Hang on, we're gonna do these problems again in a second, a different way. But right now, let's finish it up. How high is the ball after 1 second? So again, I'm back to my same equation right here, the same formula. For part C, how high is the ball after 1 second? Isaiah, what do you think? Say it again. Put T, put 1 in for T. Put 1 in for T. Why is he putting 1 in for T? Because T is time, and 1 second is time. So that's negative 16 plus 18 plus 12. I got 14 feet. 14 feet above the ground. Be careful here. What is getting squared? Here's my equation. What's getting squared? Just 1, right?
Yes.
Don't do the 16. It's negative 16 times 1, and 18 and 12. Now, I know I've been erasing because I don't have much room on this board. But in the very beginning, we did this equation, okay? For part A, it said when is the ball on the ground, so we put 0 in right here. So in other words, we took our equation and we plugged in a number. We plugged in 0, because this is height, and on the ground is 0 high. Then it said, for part B, when is it 15 feet above the ground? Same equation, but this time we put 15 here. Because again, that is your height variable. Then the last question said, how high is it after 1 second? So we put 1 in right here, because 1 second is the time variable. You will have a question like this on your test, okay? Plain and simple, preliminary test. Might also be a semester exam question. You are going to write your formula right here, plug in your numbers, and then you're going to use that equation to answer everything. Okay? So now we got one more to do, but this time we're going to do it totally on our calculator. So I have done this one. I've done a lot of math by hand. I did use my calculator to help me with the decimals, but now I'm going to do it totally with my calculator. All right, so here we go. Question 4. Question 4. I gotta get my formula. Again, you will not have to memorize this. I will give you that. That will be written on your paper. Now you read the problem and plug in your numbers. Okay? So, number 4. The rock is thrown from ground level. What does that tell you?
0.
This is 0. That is your initial height. It's on the ground. Thrown from ground level with an initial velocity of 32 feet per second. Where does that go?
Right there.
So your equation is negative 16t squared plus 32t I'm not gonna put plus 0 because that just confuses me, but that is my equation. So this is the equation.
So we got a different equation now?
Huh?
We have a different equation?
Because you have a different starting place and you have a different initial velocity. Okay, question 1. When will it hit the ground? Well, who remembers, look at your equation, this is height, this is time. When does it hit the ground? What do you know about a ball on the ground? Its height is 0. So we're going to put 0 in right here. Alright? This equation is a lot easier than the last one. We're still going to use our calculator so you see how it works. Okay? So, I want everybody. Remember, where's your grapher? Gotta have one. You remember, I need everybody to put that equation in. So you remember how to go to y equals in the top row.
No,
Y
it's just like you can't see it,
equals,
man.
and put in an equation.
She has to fix it.
Who else doesn't have a grapher today? I have one, but it's dead. That's the same as not having one, right? Guys, we can't get good at this if we don't practice. You have a charge for that? Yeah. So then I want you to take it over and get my charger, and then you can get it tomorrow, okay? Or if you'd rather put it in tomorrow, whatever. You don't have to charge it, use my charger. Who else needs a copy? Oh, you guys just have one? Ronnie, does that not work?
Here's your name on the back of it. I will put it on the back
Ryan, where's
for
your
you.
calculator? I'm here.
Unless
Are
you
you
wait.
on here? All right, get it out.
Somebody takes it.
Okay. Where's your, you guys? All right. Okay. So we are gonna do y equals,
How do you do a T on the calculator?
no, we're gonna use x.
Oh, okay.
You don't wanna get that t will be some other kind of equation. We're gonna use x.
Thank you.
This is y and this is x, okay? So nothing's changing. Okay, so go to y oops. I've got stuff in there, so I just have to clear. I just hit clear and it goes away. But we go to y equals right here. And we're gonna plug in negative, using our negative sign, 16x, I know it says t, but t is the same as x squared plus 32x. You already answered that, Ryan? Who doesn't have a calculator? Every time you don't have one, guys, it's gonna cost you 50 cents. So please, figure it out. This wastes so much time. So we got our equation typed in. All right? Now, I want you to think about something for a moment. Or actually, just hit graph. Just hit graph and see what happens.
Straight line.
Okay, so I don't know because I did my calculator away, but are you telling me who's got a picture?
Why is mine on
Oh,
here?
well, hers,
It's like
yeah, hers looks like this. Now,
Mine is on the
do you, everybody should see something going up. You might not see the top. Do you see the top?
I don't know if it's
And
still
then it comes back down, right? So here's what I want you to do. I want everybody to go to window, you don't need to, but I think this is a one I'm gonna have. Go to window, this button that says window. Okay? And you need to set your X min at like, she's got -10, okay? And then go down and set X max at 10. And then set, don't change the scale, go to Y min and put -20. And Y max put 20. Now hit graph. Now do you see something that looks like that?
Yeah.
So, what happened, guys, was your parabola went too high in the air. So you went in and changed your Y to a bigger number so that you could see more. Okay? You can always do that. Change it so that you can see what you want to see. Okay. Now, when is the ball on the ground? Right here and right here. Okay? These are the zeros. We talked about this before. So I need you to second calc 0. Remember that? Second trace 0. And your cursor should be showing. Where's your cursor?
Origin?
Is it like right here?
No.
All right. So move it left, a little bit left, and hit enter. Okay? Then move it right until you're up here somewhere. You gotta go past your point and hit enter. Then move it in there and hit enter. And it will say at the bottom, the 0 is where? 0. Okay. So when is the ball on the ground? At 0 seconds. That makes sense because didn't we kick it from ground level? So at time 0, it's on the ground. We're interested in this one. So now we're going to repeat. Second trace 0. Move the cursor so it's someplace over here somewhere. And hit enter. Then move the cursor till it's down here somewhere and hit enter. Then move it back up too close to here and hit enter. When does the ball hit the ground? 2 seconds. 2 seconds. How high will it be after half a second? Well, we could do this on the calculator, but we don't need to. If we want to know how high it is after half a second, aren't we just gonna plug in 1/2 of the time? So we can do that without graphing. If the fraction bothers you, type in 0.5. I got 20, but that could be wrong. Yep, it is wrong. It's actually 12. So if you take negative 16 times 0.5 squared plus 32 times 0.5, you should get 12. Did you get 12? How high is the ball after half a second? 8 yards. Alright, last one. When will the ball be 20 feet high? Remember, this is your equation. What are you going to do if you want the ball to be 20 feet high? You're going to put 20 here. So 20 equals negative 16t squared plus 32t. So let's get it set equal to 0. And then you're going to graph that on your calculator. Type the y equals, and type that in.
Oh, wait, I think I know.
You're typing in a different equation because now you got to
I
put
think you
extra
have to
one
type
in
in
there.
Cause like, when you type in the equation, I think you forgot to.
You should see a parabola.
Why does it keep saying error? Because when I press it, it just goes. As soon as I press it, it just dies.
Can I see the picture? Uh-oh. Did your picture, I think she's right, did your picture look like this kind of? Wait a second. We're supposed to find the zeros, right? And aren't the zeros where we cross the x-axis?
Yes.
Does this thing cross the x-axis?
No.
Never. When is the ball 20 feet high? Never. When you threw it up in the air, it didn't go high enough. It never got to 20. And how do I know? Because it never crossed the x-axis. Yeah, never. Yeah, it never crosses. It never gets that high. All right, that is the end of P7. That homework will be due on Monday. Tomorrow, or whenever I see you tomorrow, I can't remember, whenever I see you, we will begin our review. We will have 3 days of review, count them, 3, and then we will have our test. Got it? Whenever that works out to be. If you have a calculator, come bring it to me, and you will get your lanyard back. Bring your own calculators. I'm becoming a wealthy woman. Or actually, I had to go over Kennedy, oh my God.
Yes.
Did you put it in right though?
I think so.
Okay. Yeah.
It does charge.
Bye.
Wait, come back.
What's the matter?
Oh, I was seeing if